So we have completed get functionality as well on a singly linked list, right? Now let's try to perform a set functionality on a singly linked list. So what exactly a set functionality does is, as the name indicate, it's basically used for updating the value of a particular node. So as part of this implementation, what exactly we will do is, we will try to take the index and we will also try to take the new value for the node. So as part of the set functionality, what we will do is, we will try to reach the node that is available at the index given by the user, and whatever the value that we had in that node, right? And we make sure that we are updating that value with the new value. So that is the set functionality on a singly linked list, which is basically used for updating the value that is available at an index that is given by the user. Okay, since we are taking the index from the user, right, we know what all are the possible indexes for the singly linked list nodes, and it will start from 0 and it will end at length of the linked list minus 1. That means the indexes of the singly linked list that you see on the screen will be something like this. So as part of the set implementation, let's say the index that user gives is, let's say, 3. I want to update the node that is available at index 3 to a new value, let's say some text ABC. What we have to do is, we have to reach the node that is available at index 3 and we have to update the value that it currently has is test, right? And we have to update the value to ABC. So that is the main purpose of the set functionality. So what all are the different cases that could come? So obviously, just how we implemented in the case of get functionality, right? Whenever we are taking the index from the user, basically there could be two scenarios. One is the index that user is giving is valid index, or it could be an invalid index. And based on the value, new value, we don't have any restrictions, right? Singly linked list should store any value as part of the node's value. So there is no validation on the value that user is passing. The only validation that we have is in terms of the index that user is passing. So the different cases would be, first would be to check if the invalid index, and the second condition would be to check if the valid index. Okay, so we have to handle these two scenarios, right? But the thing is, by handling all those scenarios, we have already implemented a functionality called get functionality, right? And it will basically take the index, and based on if the index is valid or not, if it is a valid index, we will return the node that is available at that particular index. If the index is invalid, we will simply return null or none based on the programming language that we are using for implementing. In the case of Python, we will simply return none. In the case of Java or JavaScript, we are going to return null. So we are returning the entire node object. That means that node object that we are going to get as part of the get functionality will return the entire node, right? That means it will have the reference to the next node, and it will have the value as well. So if we can simply reuse the get functionality, we can simply update the node dot value with the new value that user is passing. We can simply update the value of a particular node. So we don't have to write the logic that basically handles invalid index and the valid index, the iteration logic that we have to write, right, to go to that particular node. The similar logic that we have written in the case of get functionality, we don't have to write all those things, and we can also basically reuse one of the functionalities. That is the main purpose of implementing any function, right? So we can simply reuse the get functionality here. So how will we reuse? We will simply call the get function with the index that user is passing. If the get function returns null or none, that means that it is a invalid index, because in the case of get implementation, if you remember, we will only return null or none if the index is invalid. Otherwise we would obviously return the node. this basically indicates that it is an invalid index. That's why we will simply return false, indicating that we haven't updated the node. Okay, otherwise if it is not null or not none, we have actually written the node, right? On that node, it is a singly linked list node of type node that we have defined. As a result, we can simply use that node dot value equal to new value. In this, by doing simple operation, we will be able to update the value we have in the node that is given at the index that is also given by the user. Okay, so that is how we reuse the get functionality for implementing the set functionality on a singly linked list. Okay, I hope things are clear to you. So far we have seen how can we implement the set functionality on a singly linked list, right? And the way I explained the logic is almost similar to how we write the pseudocode only, but anyway, go ahead and let's try to write the clear pseudocode for this. Okay, so as part of the set implementation, what exactly we will do is we will write a function called set, and here we will be taking two arguments from the user. One is index and the other will be new value that we want to use for updating the node's value. So obviously, as part of the set implementation, immediately as soon as index is involved, right, we can simply call the get functionality that we have already implemented, and we will simply store it in one variable called node or something, right? And this get functionality is already implemented for valid indexes as well as invalid indexes. So in the case of valid index, it will simply return the entire node object, and in the case of invalid index, it will simply return null or none. If we are using Python, it will simply return none. If we are using Java or JavaScript, it will simply return null. So whatever the node return value that we are getting from the get functionality, right? If this node is null or if it is matching with none, that means that it is an invalid index. Here we can simply return false, indicating that we haven't updated the node because the index is invalid. So obviously we will not have the node at that index given by the user. If it is not equal to null, right, that means else block, what we will do, we will get the entire node object. So on that node we have dot value, right? We can simply read value of that particular node and we can simply assign new value to that. So how will we do that? So we have the node inside the node variable, and we can simply do node dot value equal to new value that user has passed. In the end, we can simply return true, indicating that the updation is successful. So that is how we write the pseudocode for the set functionality on a singly linked list. One thing that you have to understand here is, here our logic is completely based on the get functionality, right? So after that we are simply checking if it is a valid or invalid index based on the return type of the value, and we are simply returning true or false, and we are simply assigning new value to the value variable we are maintaining inside a node if it is a valid index that is given by the user. So obviously as a result, the overall time complexity and space complexity will be exactly similar to what we have inside the get functionality, because the overall time complexity of set implementation will become the time complexity of get functionality plus whatever the additional logic that we are writing. As part of the additional logic, if you see here, right, all the logics that we are doing are simply checks and assignment operations, and obviously they will take only constant amount of time. As a result, the overall time complexity will be similar to get functionality, and the overall space complexity will also remain similar to the space complexity that we have in the case of get functionality. Okay, so that is what we have in terms of writing the pseudocode for set functionality on a singly linked list. Let's try to write the Java implementation for the set functionality that we have discussed. So first I will define a public the return type will be Boolean, because I just want to return true or false based on whether we are able to update the node's value or not. And let me just call the function name as set. Basically it will take the index, so the index is of type int, and it will also take the new value for the node that is available at this index, right? So the type of the value that we will be storing will be object, because we need to support the heterogeneous data in the case of singly linked list. So if you remember the pseudocode that we have discussed clearly, right? What we have to do, we have to go to the node that is available at this particular index, and we have to update the value of that particular node with the new value that we have been, given by the user. So if you remember the logic clearly, right? Going to this index is nothing but get operation. So we can reuse the get operation here. And you already know the get operation has been handled for all the situations where the index is non-valid too. So in that cases, basically the get function will return null. So based on this return, we can use the get function to update the value or set the value available at that particular index. So for that, what I will do is, first I will simply call the get function with the index that user has given, and I will store the node, okay, and I will simply store it in some variable called node, okay. Once we have this node, right, if the user passed index is in an invalid index, in that case we will basically get the null in the node variable. So we will simply check if the node is equal to null, that means that the index is invalid one, so we are not able to update the the value at that particular index. That means that node itself is not available, that's why we've got null. So in that case we will simply return false, indicating that the value we are not able to update. Similarly, if this is not the case, that means whatever the node that has been returned by the get function is a valid node. So in that node, how will we update? Node dot value equal to value that user has passed. If you want, you can name this variable as new value also, so that we will be able to have a certain distinction. So we'll simply call new value. Okay, since we are able to update the value of the node available at that particular index with the new value that user has passed, we will simply return true. Okay, that's all it is. It's a very simple operation. We will simply reuse the get functionality that we have already implemented, and if the get functionality returns a valid node available at that particular index, we will simply update that value. If it is not a valid node, that means we will be getting null from the get function, so obviously we will not be able to update it, so we will return false here. Okay, this is a set functionality. Now let's try to call this and see if it is actually able to update the results. For this, what I will do is, before updating I will traverse the entire linked list once, and after traversing, let me just update the sll.set. Let me just pass the index to 1 or 2 or whatever it is, whatever the valid index, that is from 0, length of the singly linked list minus 1, and the new value that I want to store is, let's say, my name Sai. Okay, and after set, let me just traverse once again. Okay, that means whatever the value we have this codingpal.org, I should get the value Sai, because we are trying to update the or set the value at index 1 with the value Sai. So let me just print out a separator so that we will have a clear distinction between before and after update. Okay, if I try to execute it now, run as Java application. If you see here, in the before updating, whatever the traverse function we have called, it printed 10 codingpal.org true and 10.0. After set, the index 1, which is codingpal.org, has been updated to Sai. So the resulting linked list is 10 Sai true and 10.0. Okay, similarly, if we pass any invalid index, let's say 12 is an invalid index. The possible index is from 0 to 3 in the linked list that we have here. So if I pass 12, it should not update anything. So whatever the values we have in the linked list, it should have the same values. If I execute it now, run as Java application, see, in before and after we have got the same values. Similarly, you can update the value at third index. That means 10.0 will get updated to psi. So if I run it, run as Java application, and you can see 10.0 has been updated to psi. But in this case, one more thing that you can print and verify is head dot value, tail dot value. Here, if we update the value at index 3, we are ultimately updating the tail node from 10.0 to psi. So if we print it, we should be able to see that value getting reflected in the tail node also. So if I just run it, run as Java application, see the tail node which was 10.0 has been updated to psi. Okay, so this is a very simple operation. That's why you need to understand get operation clearly. Once you have a get operation, you will simply reuse it for setting or updating the value at a given index by the user with the new value that is also passed by the user. Okay, that's all for this set video, and I'll see you in the next implementation.